Lesson 14, Outliers. Learning target: I can find values that are outliers, investigate their source, and figure out what to do with them. Before we talk about outliers, we need to know exactly what they are. An outlier is a data value that differs from the other values in the dataset. Outliers can either indicate error in the dataset or an interesting case to study more closely. There are two different types of outliers. One type of outlier are those that are much more than other values, and the other type of outlier are those that are much less than other values. To determine if a value is either a more than or a less than outlier, we think about how the values relate to the IQR, the interquartile range, and the quartiles. Let's start with more than outliers. Here is an expression where x represents a value that might be an outlier. A number x is a more than outlier if it's greater than the sum of Q3 and 1.5 times the IQR. Now let's think about outliers that are much less than the other data values. A less than outlier must be less than the difference of Q1 and 1.5 times the IQR. Now that we have a definition of outliers and an understanding of what they mean, let's take a look at a couple examples using a box plot. Let's first analyze the minimum of this box plot. Is the minimum an outlier? The minimum of the dataset is 1. We can see that 1 is less than 1.5 times the IQR less than Q1 as it's beyond the range. So it is an outlier. But let's check this using our outlier expression. X is less than Q1 minus 1.5 times the IQR. The IQR is 13 minus 9, so the IQR is 4. So if we use the expression 1 is less than Q1 9 minus 1.5 times 4, we can simplify this. 1.5 times 4 is going to give us 6. 1 is less than 9 minus 6. We can simplify this one more time. 9 minus 6 is going to give us 3. So now we have 1 is less than 3, which is true. So we indicate that this is an outlier with a check mark. And we know that 1 is an outlier because 1 is less than 3. Let's take a look at the maximum. The maximum of this data set is 24. We can see that 24 is more than 1.5 times IQR plus Q3 because it's beyond this range here. So it is an outlier. But again, let's check this using our outlier expression, or x is greater than Q3 plus 1.5 times the IQR. So if 24 is our maximum, is greater than 13, which is Q3 plus 1.5 times 4, we can simplify this. 1.5 times 4 is going to give us 6. 24 is greater than 13 plus 6. Simplify and add the 13 and 6 together. So now 24 is greater than 19. This is true, so we put a check mark because it is an outlier. And we know this because 24 is greater than 19. Now we're going to take a look at a real-world example. This box plot displays the resting heart rates in beats per minute, BPM, of 50 athletes taken 5 minutes after a workout. Is the maximum an outlier? We also see our summary statistics below the box plot. Let's take a look at that maximum. We can see the maximum is 112. We can also see that that maximum is more than 1.5 times the IQR plus Q3, because Q3 is right here. So by the looks of it, it is an outlier, but let's double check. Again, using our equation, 112 is greater than 76 plus 1.5 times, and we're going to say 14. And we know that IQR is 14 because Q3 is 76 and Q1 is 62. 76 take away 62 is going to give us 14. Let's simplify. 112 is greater than 76 plus 21 because 1.5 times 14 is 21. Simplify again. 112 is greater than, add these two together, and we get 97. Yes, indeed. 112 is an outlier because 112 is indeed greater than 97. In order to understand outliers, we also need to recognize that they are not always representative of the whole sample and that their presence can disproportionately affect the values of the mean, MAD, and standard deviation. So we need to think about if we should eliminate an outlier we just found. After reviewing the data collection process, we realized the maximum heart rate of 112 was taken 1 minute after a workout instead of 5 minutes. Should we remove this outlier? We keep outliers in two situations. The first situation in which we keep an outlier is when the data point is taken under the right conditions and is simply an unusual value. The second situation in which we keep an outlier is when the situation cannot be revisited to determine the source of the value. We cannot tell whether there was an error in the data collection or the data entry process, so we need to keep it. There are three situations in which we eliminate outliers. The first situation is when a data point is a confirmed error in the data collection or the data entry. The second situation to eliminate them is when the data point does not represent the sample as a whole. And our third situation in which we eliminate an outlier is when the data point is not obtained under the right conditions. So should we remove 112 from the dataset? Yes, because the outlier was not obtained under the right conditions. We know that the athlete's heart rate was taken just 1 minute after the workout instead of 5 minutes, so we should delete it. If the measurement of 112 beats per minute had been instead found to be taken under the right conditions and was merely an athlete whose heart rate did not slow as much as the others, it should not be deleted, so that the data does reflect actual measurements. This is why the source of any possible errors should always be investigated, and we should not delete data values unless they can be confirmed to be errors in the data collection or the data entry process. Now that we know when an outlier should be removed, let's think about how the data changes. The box plot in yellow shows the data with an outlier. The box plot in red shows the data without the outlier. How does the data change? Let's start with the mean. The mean with the outlier is 69 and 78 hundredths beats per minute. Without the outlier, it's 68 and 92 hundredths beats per minute. This means that it decreased by 0 and 86 hundredths beats per minute. Generally speaking, removing outliers can greatly change the mean since it's affected by extreme values. Removing outliers can have a large effect. The median with the outlier is 70 beats per minute. The median without the outlier is 70 beats per minute. So we see no change in the median. Outliers have little effect on the median and the IQR since it depends on position, not exact value. The median and the IQR is much more resistant to change since it measures the middle of the data based on the number of values rather than an actual numerical value. And now let's look at standard deviation. The standard deviation with the outlier is 10 and 71 hundredths beats per minute. The standard deviation without the outlier is 8 and 9/10 beats per minute. So the standard deviation decreased by 1 and 81 hundredths beats per minute, which is about 17%. This means that our updated data without the outlier has less variability. Just like the mean, standard deviation can greatly be affected by outliers, making variability appear larger. Standard deviation uses numerical values, so outliers cause large changes.